right, so what we're working with now is we're going to work about representing relations and functions, and really we have to determine what a relation is and what a function is. So a relation, let's highlight everything. Oops. A relation is just a set of ordered pairs. So remember, it's x, y. When we talk about relations have two things. The domain is the x value, or the first values. It is also the independent. And then the range is the y, which is the second values, and that's the dependent. So remember, domain goes left and right. Range goes up and down. So we've had basic domain and range before in Algebra 1, but when we get through the Algebra 2, a big thing is I'm going to give you different functions, like things like this, and you have to be able to say the domain and range on them. Okay. All right, so a function, a relation is a function if and only if each of the same x values is paired with identical y values. I'm going to insert some space. So the best way to think about it, I think, is to think about going to a party. I like to explain this. So let's give an example of a function. So I have these ordered pairs, and what happens is 3 always goes to the party on 5th Street, right? And 2 always goes to the party on 1st Street. And then maybe there's 4. He also likes to go to the one on 5th Street, which is fine. And then I also have a 6. Maybe it goes to -5. If you notice, I have all these different x values. So when you have different x values, it's automatically a function. What happens if you have the same x value again? If I throw in a 2 again, it must go to the same place as the 2 did over here. So if I have the 2, then it must be 2 with 1 here also. They have to be the same. So if you have the same x, then it also must be the same y. That's what makes it a function. Okay, not a function is what happens when one number tries to go 2 places or to 2 parties, which can't happen. So let's say I have 2 and -3, 5 and -3, that's okay. But now 2 I have with 6. That's an issue. The issue here is that 2 goes to -3, but then over here it also goes to -6. That cannot happen, okay? So if you have the same x, if same x must be the same y. So since it's not, that is why this one is not a function, because 2 went to -3, and then over here it went to 6. So let's skip down here and let's do some of these problems. We're not going to do inverse, we can cross that off. So we need to list the domain and range, and then we need to ask ourselves if it's a function. So why don't you go ahead and try these 3 and press pause when you think you got it, or press play when you think you got it, so you can come back and see. Okay, so let's look at this first one. My domain is my first number, so 2, 5, 1, and -2. Now, since I see that there's no x's repeated, I already know it's a function. Okay? And then I have my y's, which is my range, -3, -6, yeah, -4, and -6. Now, because I already wrote this -6, I don't have to write that other one again. So I'm going to go ahead and erase that because I don't need that one. So that one's gone. Okay, so if a number repeats, you don't have to write it again. All right, so let's look at this next one. Remember, our domain is our first one, our independent. So our domain is our top numbers. These are our domain. So 2, 4, 7, 10, 12, 8, and 9. And again, none of these numbers repeat, so it's an automatic yes. And then here, the range is 5, 7.5, 10, 8, 12, 6. And I already wrote an 8, so I'm not going to write the 8 again. So this one's there, but I don't have to write it again because I already wrote it. All right, this one here, this is called a mapping. There's my mouse, there it is. And with a mapping, these first numbers is your domain. And so your domain is -3, -1, 2, and 4. The way this works is that -3 goes to 1. So that ordered pair is -3, 1. -1 goes to -2. So that's -1, -2. 2 goes to 1. But then look, 2 also goes to 3. So right there, that's an issue. There's 2 lines leaving from the 2. So that tells me that this is not a function. And so my domain is these numbers. Over here, this is my range. So my range is -2, 1, and 3. So when you have lists or points or tables, it's just you list your X and you list your Y. Now sometimes you're going to have graphs, and so let's see if I can insert some space. That didn't work. It's okay. All right, so sometimes you're going to have graphs, and so when you have a graph, what you're going to do is you're going to determine if it's a relation by performing a vertical line test. If the vertical line touches the relation in only one place, then it is a function. So if I have a line like this, right, and I draw a bunch of vertical lines, it's not working, and I draw a bunch of vertical lines, each time it can only touch one place. And since it only touches one place at each vertical line I can ever make, then that's a function. This sometimes is called dropping bombs. I don't have fancy bombs. My bombs blow up once and they go straight down. So I call that dropping bombs. All right, so let's look at this next one. The first one we have to do is determine if it's a relation. So I drop a bomb. There's one blow up, and there's some more. Now, since it blew up several times, that is kind of crooked, but here, if I was able to draw a straight line, you notice it's going to blow up 3 times. So this one is a no. This is not a function because my bomb blew up multiple times. Now, I do need us to find the domain and range. So this gets a little trickier because the domain, you have to think about the X. So the domain is the X, and the X goes to the left and to the right. And if you notice, these arrows go to the left and the right, so your domain is all reals. For the range is up and down. Well, this arrow does go down. It's slow, but it goes down. And this one does go up. It's pretty slow, but it's creeping up. So this one goes both up and down, so it's also all reals. All right, let's look at the next one, change color so it's easier to see. So first thing I do is I drop some bombs. Boom. And boom. Everywhere I drop a bomb, it only blows up once. So this is a function, yes. And so our domain and our range, our domain, remember we look to see if arrows go to the left and right. Well, this arrow is going up and to the left, and it's going to keep going all the way up there. And this arrow here goes up and to the right. So since the arrows go to the left and right, it's all reals. The range, though, only goes up. So range is y. Since it goes up, this is the lowest point it goes. So I'm going to say it's greater than or equal to -4, because that's what that coordinate is, 1, 2, 3, 4. All right, over here, we drop bombs again, so I drop a vertical line there. It's only 1, so that's good. That's good. Now this is the one that's going to be tricky. It blows up here, but you see this? There's a hole there. It means it passes through the hole but doesn't blow up. So it really only blows up once. And that's the only place that it would have possibly blown up twice. So this one is a yes. Your domain, again, is left and right. And this has arrows going to the left and to the right. So this is all reals. And range is going up and down. This one's only going up, so it's greater than. But the difference here is if you look at this window, there's a hole there. So it doesn't include that. So this time I'm going to have to say that it's greater than, not equal to, just greater than -2. All right, the last thing we have to talk about today is function notation. Function notation is something like this, f of x, g of x. It's just another way to write it. But really all you're going to do is plug things in. So f of x, I'm going to use the f function. So I like to write that function again so I know what I'm using. Instead of -2, instead of x, I'm going to plug in a -2. So I get -6 minus 4. So I get -10. I ran out of space. It's not x equals -10 because all I'm doing is substitution. It's just substitution. All right, for number 5, it's the g function, so I like to write the g function so I can see it. And this time my g function is 3, so I need to plug in the 3 to both x's. So 3 squared is 9. So I get 18 plus 9, so I get 27. All right, on 6 and 7, you'll notice that there's stuff on the outside. And what you do when there's stuff on the outside is you just focus on the inside first. So again, it's the g function. So I'm going to write my g function. And I'm going to highlight this thing, so I'm going to come back for it. Right? I'm not going to do anything with it now. So now I plug this in, and instead of x, I'm going to plug in -4. So 2 times -4 squared plus 3 times -4. -4 times -4 is a positive 16. So I get 32 plus a -12, so I get 20. Well, you would be done, but you still have this plus 5. So now I take care of that, and 20 plus 5 is 25, and that's your final answer. All right, this last problem on the right, again, I'm going to focus on the inside. I'm going to ignore this right here. And so I'm using the f function, so I'm going to write the f function. It's 3x minus 4. Instead of x, I'm going to plug in, Instead of x, I'm going to plug in a -5. So 3 times -5 minus 4. So that's -15 minus 4, which is -19. But then I'm not done because I still have this 3. So I need to bring this down in front. And that becomes 3 times 19, which is 57. So the answer for this problem is -57. So when you're doing these, remember that you just have to do the function first and then focus on the outside things.